My name is Pat Lindeman. I'm the Ingham County Drain Commissioner. I'm standing in the middle of the Montgomery Drainage District, and it's a unique system that we've created here. It's got waterfalls, ponds, open area, grass. It looks and smells like a park. It's got all kinds of different wildlife features that we've added to it. But there's one thing you can't see, and that's the tardigrades, which are microscopic. You can't see them with the naked eye. You have to use a microscope to see them. And they have 8 legs, and they eat algae. The algae, the reason that they're important in this system is that the algae we produce takes out the phosphorus within the water column. So the pollution phosphorus is in the water column, and the algae eats it, and then the tardigrades eat the algae. And if they eat the algae, then their waste product is loaded with phosphorus, and it all falls to the bottom, and it doesn't hurt anything, and it'll last, I don't know, 75 to 100 years before you have to scrape the bottom clean, take it off to the landfill. This whole water balancing act has to be performed as an ecosystem, and it has to, you have to understand all the microbes and all the different critters that make it work. The ducks play their role, the frogs play their role, and so on and so forth. And because we just opened this up to water, it started to fill up a little bit, but once we get a consistent source of water and we have a couple overflows to the river, I doubt whether we're going to have the high population that we're looking for. Now, if you go to the toll gate drain, that's got a lot of them in it, and they overwhelm the system. And there's no algae blooms at the toll gate because there's so many tardigrades eating them. And tardigrades have their own system. They're an animal, of course, and they have 8 legs, and they eat the algae. But there's other things out there that eat the algae as well. Plus, we're not just taking care of algae. We're doing about 60% of the 75,000 pounds of pollution that's distributed through this water annually. 60% of that is bio in nature. And all those leaves, the grass clippings, all of that stuff that comes up, all the other biodegradable pollution loads depend upon these bugs to decompose it. Once it's decomposed and it enters the water column, it can be sucked up by these plants and the aquatic vegetation I have in there. And removing this pollution depends upon those bugs being active, and it depends on you having a lot of them. So we'll have to have them, and with all the other bugs that build condominium sites on the tree limbs and the dirty leaf system that this thing has. We try to create a balanced ecosystem, and you can see how the water is running through here, adding oxygen for their life so that they live. And we have all of this is part of a bigger ecosystem. 80% of the land is impervious, 85% I think was what we figured. Now, what that means is that 85% of the land doesn't take any water into it. So you have to have a place to hold the water and to process it. You have to build an ecosystem to do that. Now, we can do it artificially like a wastewater treatment plant, but that not only smells, it has other things in it and that kind of stuff, so it doesn't really work well for stormwater. However, these work really well. You build it and they will come, and we'll get the bacteria, we'll get the kinds of bugs that are necessary to make this system work right, and we'll make it work. And we think that this is the new wave of how we're going to build stormwater infrastructure in all our urban areas. We can do the same thing with rural areas at little to no money. You can save probably 80% of all what you would traditionally spend on concrete, piping and so on, if you build systems like this. This is soft infrastructure. The type of system we built is an ecosystem that is a balanced ecosystem, and we need to keep it balanced. If we ever find that it's too much algae, we'll take the algae out and by hand. If we don't have enough bacteria to eat it, like these little bugs. Other than the fact that there are some bacteria that help this system and don't hurt it. But the point is that this water, if you put enough oxygen in it, you'll make enough for all these animals to live. From here, Grand River to Michigan Avenue, there's 11 waterfalls. They're all putting oxygen in the system. This pollution would normally go to Lake Michigan and fall out. None of it's going to go to, not a drop of this, maybe about 4% of the pollution that normally came was around 75,000 pounds annually. Only 4% of that will make it to the river, and it depends on when the weather breaks and when it rains and when it snows and how much it snows and all that kind of stuff. We studied it for 3 years in a row, and we found that between 50,000 and 75,000 pounds of pollution was generated from this 1 square mile. This is the new wave of infrastructure for stormwater management that's going to take place. So I think, as far as I'm concerned, it's 80% cheaper, and it builds a place where people can walk and ride and picnic and just have a good time, you know. And it's a park-like environment. It looks like a park, smells like a park, only it's not a park, it's a stormwater facility. This is the toll gate drain, and its watershed is just shy of a mile square, and it takes in more residential homes, and it doesn't have the imperviousness that the Montgomery drain does, for example. It also includes a golf course across the street. This pond here is like a condominium for microorganisms, and they like chewing on the dead wood, and they like chewing on the dead trees and all that kind of stuff. And I can usually, in this, I can find all kinds of microorganisms. And the one that we're interested in the most is the tardigrade. It eats the kinds of pollution that we want to get out of the system. So it's imperative that we have a healthy population of those. So I try to check the population every year or so. I make a trip out here and I take water samples. And most of the pollution is eaten up and gone by the time it makes it to the golf course. And when it gets over the golf course, they use this water to water the fairways, which again uses up the water. And I have enough room in this watershed, in this system, to hold a 500-year storm, which means that not a drop of water goes into the Red Cedar River. Mm-hmm. Not a drop. We're going to clean the world one drop at a time. If it's the last thing we do.